Hello everyone. Good day, everyone. Welcome to another episode of Build Your Portfolio with me. We are doing an interesting project today. We are doing an interesting project today, the student performance. But before we go there, have you ever wondered how do data analysts or aspiring data analysts get their data or a dummy data set to work on to practice their analytical skill? So that would be where we have to we'll be starting with. We'll be starting from there today. But before you continue, please like and subscribe. So today you want to go to any browser of your choice. So you just click on cargo.com, and obviously if you don't have an account with them, you have to sign up. So because I already have an account with them, so I think I should have the home page. I should be the landing page should be my home page. Okay, so I already have an account with them, so you can easily just you will see something like this: sign up, login. Just sign in like you would do if you log into a normal website. So you want to click on the data set because you actually want to use a dummy data set. So in this case, we are looking for an interesting project called students performance. So you can actually ask about any topic of your interest, student performance in exam. So yeah, so let's pick the first one, the one by Jackie Seixas Pampo. So that's very good. So we can see we have about the data sets, right? We can see we have the data it will cost if I actually download this. Then we can see we have the column header. I can see where that we have 8 columns here. I can see a brief um a preview of this CSV of this file, and I can also see that this file is also a CSV file. Also, if I download it, I will only have a one file downloaded with 8 columns. So, and I can see we have um most especially people are using it for education, standard testing, data visualization, EDA, EDA, that's exploratory data analysis. And we are actually using it for exploratory data analysis today. That's the EDA. Basically, we are just exploring this data to know what is the causative factor or what are the students' performance in this particular school. So the next thing I will do is we have our download button here. I can download from this button. Then I can also download here by clicking on this. Then I can see something like download data sets as zip. If I can download here, it will only cost 9 KB. So let me just download here so we can see how it looks like. So you can see it has downloaded. So I just click on this file here, and obviously I should be able to see it in my download file. So I have student performance one. I already have a student performance already before. I just do this as a form of education for us. So the next thing is we are actually exploring the data sets in Python. But I know most of us might not have our Python installed, which is why we'll be using what we call Google Colab. Also on your browser, just search for Google Colab. GOGE, that's Google. Google, that's Google, then Colab. So also you have to sign into this Google Colab. So it should not lead you here if this is if you are a first time user. I think it should lead you to something like sign up, and you have to like sign up with your Gmail account. I think yeah, you have to sign up with your Gmail account. So when you are done, you will see an interface like this, just like this. So you want to click on new notebook because this is actually a new project. So when you are done, so welcome to Google Colab. It's just like you are operating a Python, just like you are operating Jupyter Notebook. Similar interface, everything looks so similar. So the next thing here is that we are trying to explore our data set. Our data set is on my computer, so we need to actually install and upload my data set. So we can see something like file here. So let me try to make it bigger so we can see it better. So the first thing actually is upload our file here. So you can see I'll click on my file, it's connecting. Let's just give it a bit of time. Okay, good. So we click on this upload here. We can see we have a sample data already. Actually, it came with the Google app. So we just want to click on upload because I'm trying to upload my student performance here. So I can click on student performance one, which is the one I downloaded. It is showing me warning, but then it has actually downloaded, so I can see it here. So the next thing here I need to do is actually we have the Python code is what students performance, so I can just rename it here students. So the first thing we need to do is we need to import our libraries. So we can just say something like this. So let me just close this so we can see better. So if you actually over your mouse to the middle, you can see something like, are you trying to code or are you trying to write a text? So let me just write a text here. What is the text am I writing? I want to start student. Let me write something like this. Exploratory data analysis. Yeah, that's it. So the next thing we are trying to do is we are trying to import our data set. As I said earlier, you can still decide to go here, click on text and click on importing the libraries. So it depends on which one you want to do. Let's import our libraries. Then you have to go here because this particular cell is actually for writing codes. So we want to write, let's import our necessary library for EDA. That's the first one is import pandas as PD. Then the next one is you have to, sorry, these have to be in small letter. Actually, guys, Python is case sensitive. So when you are supposed to write it in small letter, you have to write it in small letter. So I have to write import numpy as np. Then import matplotlib. Import matplotlib dot pyplot as plt. Then import cbon as sns. So these are like the four libraries that we'll be using here. So is this thing clear enough? Okay, so let's run this. So you can see it is now running, everything looks good. So I can add more cells here just to write my codes. So the next thing we need to do is we need to load our data set. So the first thing is loading my data set. So let's write something like this. Loading my data sets. So yeah, I had hashtag just because I want to write a comment, but you can go the other way, click on text, then write your loading your data set. Then also, okay, now let's load our data set. To load my data set, I will write something like this. This alias I gave panda, so it will be pd dot. What am I trying to do? I'm trying to read. What is the data file? It is a CSV. You can see when you write read, it's giving me different option. Is it a CSV file? Is it an Excel file? Is it HTML file, JSON file? You can see we have all different type of file here. So I'm trying to read a CSV file. Then I'll open my brackets, then quotation mark. So I'll go to my file. Remember, we've already uploaded the data set the other time. So click on these three dots, then click on copy path. Okay, so I've copied the parts. So I can just click it like in between the quotation mark, then Control V. Just that you are pasting and you paste the URL of the file. So let's load it. So we can see we have the file here. We have the file has been loaded here. So let's save this one into a variable. Let's call the variable data frame, and in short df for data frame. So df equals to this. Now let's reload it. Okay, now so I can easily just call my df. So you can see we have our data set. Anytime I call my df, my data set will comes up. But before we go into our exploratory data analysis, let's try to let's explore a little bit. So let's see the df open bracket edge. Yeah, edge. Sorry, what am I writing? df.edge. So this df.edge will give you the first few rows. So it depends on if you want like first 10 rows, first 20 rows. So in this case, if I write it like this without writing any number there, so it will just return the first 5 rows. So you can see we have 0 to 4. 0 to 4, can you see? So if it is like df edge 10, so it will return the first 10 rows. So you can see we have the first 10 rows, 0 to 9. This one is actually a row plus 9 rows, 9 other rows. So that's what 10 rows. So it depends on what you want to do. So the next thing is let's try to get a bit of information about this particular data set. We want to do df.info, right? So we can see we have eight columns. We have the 8 columns, right? We have gender. Yeah, sorry for the interruption. So we have gender. Gender is an object which is literally a string data type. Then we have our race or ethnicity. We have the object data type. We have parental level of education. We have the object. You can literally see that we have almost all the data types here are either object or integer. So which is a good thing. So also let's look at let's explore a little bit. Let's write something like df dot. So basically, why am I writing df? Df is just like I'm writing, okay, actually give me a bit of information about this data frame. That's why I wrote df dot info. So in this case, I want to write df dot describe. That is, describe this data set for me. So this one will be control enter. So you can see it is actually given. Okay, now let's look at the data frame. We have the gender, race, parental level of education. How does it affect the student performance, the launch? How does it affect student performance? Then we have a bit of their score. We have the math score, reading score, and we have the writing score. Basically, we are trying to look at parental level education, their launch, their test preparation score, how it affects these three score, that is the math score, reading score, and the writing score. So we can see here that it is actually when we write something like this, df.describe, that is describe my data frame. Math score, we can see we have 1000 math score, basically just like we have 1000 rows actually, and we actually see why I said we have 1000 rows later. So we have the mean value, the mean math score is 66, the mean reading score is 69. That means they did better in the reading aspect. So you can see the minimum score in math, someone actually got 0. In reading, no one got 0 but 17. But in writing, someone got 10. That's the minimum value. So you can see 25% of people, the least 25% of people got 57 in their math score. So everything lows. You can just get an information, a bit of information by using df.describe. But notice something, I can only see 3 columns. So why am I not seeing? And looking at this, the 3 columns belong to integer only. That's the math score, reading score, and the writing score. But why am I not seeing anything? This describe is not describing anything about the object data type. So you just want to write include objects in between your describe. So include equals to objects. As I told you earlier, Python is actually case sensitive, so you don't want to replicate this word for word, case by case for case. So you can see now we have gender is saying that we have two gender. Basically, we have a lot of females are in this school, or we are trying to look at more females. Then we can see the highest race here is group C. Also, we have parental level of education. Most of the parents they went to. Oh no. So sorry, this top means the first row actually. This is the first row. This is the first row. Group C is the first row. Group. Then you can see here. Okay, we have our object now. Yeah. So the next thing is let's start to do something like df.shape. So when you notice this thing, I'm not writing any bracket, any open parentheses here. So I'll just load it here. So what's the significance of this? We are trying to check for the number of rows and columns. So we can see we have 1000 rows and 8 columns basically. And I think I've shown you why we have 1000 rows and 8 columns. So let's continue. So the next thing we'll be doing here is, yeah, let's try to do some data cleaning. So I can go here, then click on data cleaning. So it will just be a bit of data cleaning. So the first thing we are trying to clean is we want to look at if there is a null value. So let's check if there is any null value. Check for null value. So to check for null value, we write something like ef dot is null. So we are trying to look at this. We are saying that sum any null value in this data frame. That's what we wrote basically. So if I run this, so it is showing that we have everything here is what is zero. Everything here is zero. Everything, all the columns, there are no null value. So we have data set in everything. So also let's look at if there is any duplicate. So I've exhausted all the cell row. To get more cell row, you can see something like plus code here. Let me try to show it better. Okay, you can see something like plus code here. So I can just click on my plus code. So and also you can actually click on your B on your keyboard. You will keep having it. Okay, you can say escape B, escape and B, escape key on your keyboard and B on your keyboard. You can that's the shortcut for getting more rows actually. So now let's check for duplicates. Check for if there is any data duplicate here. So this one would be df dot um let me say duplicated. Is there any duplicate here? So it is showing dot. Let me write some. Okay, no duplicates found actually. So you can see I just said sum any duplicates you have there and it is showing zero. That means there is no duplicate here. Okay, what's the next thing we need to do? So now let's go to our EDA properly. But before then, let's try to do something very important. So if you look at this, I call my here. Okay, okay. So looking at this particular column header, you can see some of them have empty spaces. Actually, when you have empty spaces on your column, it is prone to you are prone to making mistake or the some response will be slow or it will be returning an error. So it is actually advisable that you replace all these spaces with underline. Yeah, with underline. So let's try to do that. So replacing the colon header, replacing the colon header with column header spaces. It's on the line. So to do this, you write something like def dot columns right here dot str. What are we trying to do? We are trying to replace, right? So we are saying the columns inside this data frame, replace it, and actually it is a string data type, so that's why we are writing. So what are we replacing? We are replacing empty space, right? I put it into a quotation mark, right, comma. What are we replacing it with? We are replacing it with what? Underline. So you go to your quotation mark, right, underline there. So you can see we have quotation mark, empty space. We are replacing it with what? With quotation with underline. So let's run this. So you can see all my columns now have something like this. Parental level of education, there are no empty space there. Look at this, test preparation course, no empty space there. Now let's try to save it into a variable. So what variable should we save this? Let's say something like df columns dot columns. So it is showing that now whenever I call whenever I call any columns inside this data frame, it should replace it with all of these data sets. What are all of these data sets? These are all of these column header that is devoid of empty spaces in between them. So now let's run this. So it is showing it is running. So now let's try to call my df.columns. So I can see all the columns header by calling this df.columns. So you can see we have the all of the columns without empty space now, which is very good. So now let's try to go to what we are here for today. Let's go to text. So let's write exploratory data analysis. So now we are trying to explore our data sets. So the first thing I want to call my data frame. I know we have seen this quite a number of times. So now let's start from the first column here. We want to know, actually we already know it from df.info, that is from the information we got from this data frame, that we have a lot of females than male. So we want to look at the ratio. What is the ratio of female to male? So we want to do something like this. So when you want to call a column, you can call a column in two ways actually. You can call it by df.gender by using your dot notation, or you can use your square notation. So I prefer using my square notation, so let's use that one. So once I write my square bracket, I can see something like gender here, so which is what I want. So I'll just click on it. So if you don't have the option there, you can just write it with your hands. So what are we trying to do? We are trying to count it, value counts, right? So now let's try to look at it. So it will give us the ratio of male to female actually. So we can see we have 518 to 482. Actually, this is just the number. And also we can count it. We can put it in form of a ratio by doing something like normalize equals to 2. Yeah, normalize equals to 2. All right. Yeah, obviously. So you can see female holds 51.8%, while male holds 48.2%. Actually, there are not much difference, but yeah, you can still confirm that we have a lot of female than male. So now let's just remove this normalize equals to 2. Let's write it in number, in values. So we have this. Actually, another thing you can do here is that we can actually plot this, right? You can plot this on a graph. So let's say something like I'm not sure. Let's try it. Control C, Control V, dot plots. What are we plotting? We write kind equals to bar. Let's do something like this. Showing an error. Okay. I'm sorry, that's your value count here. Dot value. Dot. Okay, let's try to plot it. Okay, now you can see we have our female and male bar. So let me try to reduce the size. So we have df dot gender dot value count. That is, we are trying to plot it into a bar graph. So if you don't want bar graph, you can actually change it to horizontal bar. So by just writing bar h. So this is better, right? Also, you can actually try to change the color. So you can say color equals to sky blue. So let's use teal. Actually, this is a color also. Let's run it. There's an error. Oh, I'm not supposed to. So you have to use American English. So this one has to be color without a U. So let's try to. Okay, good. So also we can see we have plotted it, and we can see we have more female than male. Okay, which is good. So now let's move on to the next thing we want to do here. So let me call on my data frame again. So me calling on my data frame is just to know what else I want to do, because I'm actually exploring these data sets. So now let's look at the 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 score, the skewness of the distribution of the score. What's the how many people score below average, how many people scored above average in the maths, in their reading and in their writing course. So let's do something like df dots. Um, okay, let me just plot it right away. To plot this, I'll write something like let me use a KDE plot. So let me write something like this, sorry. So let me write something like this. Checking for, let me just write distribution of scores. So to check this, I want to plot it immediately. So you can actually see how to do that also. So remember, when I was importing my libraries, I imported 4 libraries. So we have the Seaborn, we have the Matplotlib. Actually, this Matplotlib and Seaborn, they are used for data visualization in Excel, in Python. So in this case, I will just write something like SNS. Because I'm trying to look at the distribution, I'll be using the histogram plot. So I'll be using my hist plot here. So open the bracket here. So what are you trying to get? Abi, what column are we trying to plot an histogram on? So you write df, that is in this data frame. Use the square notation just to get it. We are trying to look at the math score. We are trying to plot that. So I don't want to plot this alone. Let's use the KDE charts. Don't worry, you understand what I'm trying to do. So we say something KDE equals to 2. So you can actually see when you have something like this, when I write my comma, we have a lot of stuff we can write here. So I just want to click on, you can see we have, let me try to see something. We have KDE, equals to 2. So I want to use my KDE. So I'm writing something like KDE equals to 2. So let's run this. So why I'm running this particular stuff is just that, let me try to, so why I'm running this is just that to know the distribution of the score in my among the students here. So you can see a lot of them have 40, ranging from 40 to 100. Most of them are actually are actually between within the range of 60 to 80. So now I can see the distribution of the score here. So also let's do the same thing for um so let's do the same thing. But actually you don't want to leave your what do you call it? You don't want to leave your chart like this. You have to write a title. So let's write something plt.title. Plt dot. Now we know what plt is. Remember I said matplotlib and seaborn, that's SNS, are used for data visualization. So we want to write plt dot. What are we trying to write? We are trying to write a title to this one. Remember now this particular chart does not have a title. So now let's try to give it a title. So what do we give it? Let's just write something like math score distribution. So now let's load this. So you can see we have math score distribution now. Also, you can also change this color, comma. Let's change it to, remember you have to use color without a U. Let's change it to green. So you have to put this green in a quotation mark. No, I think this is already green. Let's use red. This is already green. I mean, this is blue. Okay, you can see we have red. So we can actually say deep red. Um, oh, it does not understand what deep red is. I don't know. Okay, let's just write. Let's write black. So I think this is the blackest it can go. Okay. So let's do the same thing for reading score and writing score. So I'll just copy this one. I'll just copy that. Control V here. So instead of math score, I'll change this one to reading score here. So now let's try to look at the distribution there also. Oh, reading score. Remember, it has to it not have empty space but what underline. Now let's try to look at that. So reading score, a lot of them got around 50 to 90. Okay, the most score, the most of them actually range between 60 to 90, 80 again, which is good. And let's do the same thing um for writing score. So I forgot to add my. So let's write PLT dot title because this is our written score distribution. So this one will be sorry, am I trying to write the reading? Okay, this is our reading. So this one should be our writing score. Let's try to run this. So we can see most of them actually have around that 50 to 80 again. So which is actually good. So now let's move on. So now let's try to look at a bivariate analysis now. So we can see we have now let's go to bivariate analysis. I can just click on my text here, then write something like bivariate analysis. So when you write something bivariate analysis, just like you are trying to look at the correlation or you are trying to use two columns to make a decision. So now let's start from let me call my DF again, that is my data frame. So now let's try to look at the score by gender. Let's look at the scores by gender. So I want to write something like DF gender. No, let's write DF dot group by. That is, I want to group by gender, right? Um, yeah, DF group by gender colon. Uh, So let's say so after you have to use the square brackets first, then the second one will be what will be square. So you have to use the normal brackets first, then you are using the square bracket next. So we want the math score now. I want to see how girls got more score. So now let's just look. Let's just do the mean value. So let's try to run this. Oh wow. So now what we did here is just that we are trying to look gender by math score. How many girls have what's the mean value of girls what's the mean value of female in their maths? Also, what's the mean value of male in their maths? So we can see a lot of male performed better than female in their math score. Now I can just copy this one. Remember, I'm trying to look at the influence of gender in their uh, in their score basically. So we have so in this case, let's change it to reading score. Let me try to enlarge it for those of what I will be using from. So let's use reading score here. So we can see, wow, now we have interesting value. We have 72. A lot of female did better than male, but a lot of male did better than female here. But a lot of female did better than male in the reading score. Now let's try to check for the writing score, almost the same thing. So I'll just copy it here, then change this to writing score. So now let's look at that. You can also see that a lot of female actually performed way better than male. So why are female not performing better in math? Now that's another. No, we are exploring. We are just exploring this data set. So that is one question. But now we can easily confirm. We can easily conclude. So let me just start writing my analysis here. My text. Let me write it somewhere below. Sorry. So let's start writing what I got here. So I want to write more males performed better than female in math. Sorry, more females, or let me say females performed better than males in all courses. But but math. So that's one of our things that we've gotten here. Now let's try to continue. We've gotten that most of them they did better. They did way better in most of the female did way better in other courses that except in math. Now let's try to look at another thing. My DF, let's call our data frame again. So I want to look at how parental level of education influenced our score. So I can just write something like this. Influence of parental education on student score. So to do this, we do something related to what we did because this is a bivariate analysis. We do something like df.group by, right? So what are we grouping by? We have to write parental level of education here. So write your double quotation mark. Then we have parental level of education. So what are we grouping this by? We are grouping it by, let's start with math score. So we use a square bracket here, then quotation mark, then math score. Remember, they have to be, it is case sensitive. So I'm using, you can see all my stuff is in low value, I'm sorry, lower case. So I'm using lower case there, so you don't want to make that mistake. So let's use the main value. So what I did here is that I want to look at the influence of the parental level of education on their math score using the mean value of the math score. So now let's try to run this. So because this one is not actually, we can see 67, 69, 62 is not arranged. So I can just come here and say sort values. Let's write ascending equals to false. That is, I want it in descending order, right? Okay. Okay, good. So now we can see people that their parents have 69 master's degree. They have the highest 69.74, followed by bachelor's degree. So the people that parents are high school, they have 62.3, 62.1, followed by high school, followed by college. Actually, degree is more like NDHND in Nigeria. So when you have the diploma certificate, your child has a minimum value of 67.8 in their math score. Then their bachelor's degree, you can see basically what we can achieve from here is that um, the highest the level of education of the parents, the highest, it actually influenced their math score, probably because, I don't know, probably because of the education. Maybe if you, the more you go higher in education, the more you go high in education, the more you take education of your children seriously. So you can see people that have their parents that have their high school, parents that have their high school certificate only, have their children having the lowest score in mathematics. So you want to, you can actually plot this one. You can just write plus kind. What type of plot are you trying to do? So like, let's try to do a bar chart. So you can see we have it here. So, but I'm not trying to plot in this case. So you can actually customize this, add your PLT title, color, but we are not trying to plot in this case. We are just doing analysis. So now let's try to look at the influence of what is the next thing? So let me call my DF again. So we have some interesting facts. So before then, so let's try to write here. Also, we want to write parental level of education, influence student performance. You can just write that is. I mean, you can report this anywhere, anyhow. That is female, higher degree order, perform better. Okay. Now let's try to, before we conclude actually, let's try to look at their this is only maths. So let's try to look at the other course they are doing. So let me just paste this one here. So instead of math score, now let's change this one to reading score. It's still the same thing. Oh wow, good. Okay, let's change it to writing score. I mean, you have to like, let me just write it in another place. So let me copy this one again. So instead of reading score here, we have to write our writing. Okay, the same thing. The same thing. You can see now we can reach this conclusion. That means this conclusion is valid. Where is it? Let me just try to write Ctrl X. Let me just write it here. Okay. Okay, good. So let's try to continue. So now let's try to call. Now we have seen the relationship between parental level now. So now let's do Control Enter. Now let's try to look at launch. How has launch affected them? So it will immediately look like the same thing, but to actually shorten this class, I'll just write group and then I explain why I'm writing group plan. So now we are trying to look at influence of launch on student performance. So instead of parental level education here, so you are changing this one. You want to look at the influence of lunch. Okay, maybe because they not have lunch, does it affect their writing score? Let's try to look at that. So you can see people that have standard lunch as 70.8, which is higher than people that have reduced or free lunch 63 in their writing course. Now let's try to look at the same thing on their reading course. So I'll just change this one to reading course. So the same thing, people that have standard course, that means lunch actually affect them. But before we read that conclusion, let's look at their math score. Control V. So this one will be reading score, this one will be what? Math score. So you can see it is even very prominent here. So you can see people that have um, high maths, that have lunch, standard lunch, actually have more better scores. So it is advisable to provide lunch. So now recommendation we have here is that lunch students that have lunch perform better in their courses. Okay, now let's continue. So now let's look at the next thing. Let me call my data frame and let's look at the next thing. So the next thing we want to look at is text preparation course. Maybe how has this influenced what they have been learning? So it will always look like the same thing we've been writing. So instead of launch here, we are trying to look at the text preparation. So let me just write test prep. How has test preparation, how has it affect the student performance? So instead of launch here, we change it to what exactly is there, because if you write anything else, it will return an error. So we want to write test preparation, preparation course, right? So let's start with their reading score. So people who completed their test preparation course, can you see they have higher than people who did not complete their test preparation score in their reading course. Now let's try to Control C, Control V. Let's try to copy this. Instead of reading score here, let's try to write something called their next course, which is writing score. So the same thing, you can see people who did their test preparation course finish tends to have better score than the people who did not complete it. So now let's do for their last course, which is the math score. So you can see the same thing. So I can easily conclude that um, students who completed their text prep, so that was the test preparation, perform better in their courses. Okay, now let's do one last thing, which is called multivariate analysis. So from the word multivariate, it's just like we are doing, what am I writing? Multivariate analysis. So here we are just trying to use different columns. So it will look like what you have been writing. Let me call my data frame. So here I want to look at parental. Let me just start it. It's quite complex, but df.group by. What are we grouping by now? We are grouping by um, parental level of education. Okay, because it is we want to write a list of columns, so I have to put it in a square bracket. Then write my quotation mark. So let's start with parental level of education, right? So let's use something like this also. Math score. No. Let's use lunch, right? And test preparation. What is the test preparation course? I know we've done all of this, but I'm trying to like consolidate everything into um one code. So don't be scared actually. It's very simple. So we write the same thing for this one. So remember, after you are done with your normal bracket, you are using a square bracket. But because we are also writing a list of projects. Remember, this is a multivariate analysis. So we write something like this. We want to look at the influence of parental level of education, the influence of lunch, the influence of test preparation on their math score. Let's start from the math score, followed by what? Reading score. So followed by math reading and writing score. So because you have a group, you have to end it with a mean value. So it's not necessarily mean, but in this case we are using a mean value. So now let's look at these results. So these are basically what we've been writing since the morning. So I consolidate everything into one output. So now we have our associate degree. Let me try to, let's do something like this, sort values. So we should know what sort values is now. Equals to, sort value ascending equals to false. So that is descending equals to 2. Basically, that's what I'm trying to write. There's a mistake. Okay, let me just remove this. It is showing that, okay, I don't think ascend sort value is supposed to be there, which is okay. So let's just look at this. So we have our associate degree. If you look at their lunch, if you have a free or reduced lunch, I don't think so. We have lunch test preparation score. Okay, these are the stuff we are looking at. So if you have the parental level, the associate degree, so you have 69, 59, 73. Okay, this is actually very complex to actually decode. So let's look at this. We have math score. This is what I actually want to. Let's start from this. Writing score. Let's look at this writing now. So if you have free or reduced, this is lunch. I know this is test preparation. Honestly, I don't know how to interpret this thing, but I know I've consolidated every information I have here. So basically, you can see we have I don't know how to interpret this. I'm not sure. Oh, okay, good. Sorry, this is associate degree. Then we have our lunch. We have if it's either you have free or reduced lunch, or you have standard lunch. So if you have free or reduced lunch, let's compare it with people that have standard lunch. So people that have standard lunch, we have 73 and 68. They perform better than people that have free or reduced lunch. They have 68 and 59. So the same thing with their reading score. You can see people that have standard lunch and they have associate degree, they perform better than people that have free or reduced loan. Even people that complete their education, you can see that's the top. They have higher score than people that not complete their education. 73 and 68. Then we have 68 and 59. So the same thing here. The same thing here. So if you actually compare everything, you can actually reach the conclusion that if your parents have higher level of education, also if you are being given lunch, you are being given lunch, and also you complete your test preparation, there is high value that you will actually perform better in your education. So you can just write your recommendation. I will not be writing that, but you can just write that students are advised to eat lunch, students are advised to complete their education, as students do not have the opportunity to choose the level of education of their parents, but you can urge their parents to take the students preparation um, student courses with um, with uh, with maximum, I don't know the English to use, with maximum seriousness. Yeah, let me just use that. So yeah, that would be the end of Build Your Portfolio with Me Data Analysis Edition. Thank you so much for joining us. Have a great day. Bye.